Hi, I'm Madeline, and for my Astronomy Project 3, I will be discussing white holes. Now, this is an extremely complicated topic, so I'll only be able to look up the basics, and I'll try to explain it as simply as possible. But before we get into white holes, we need to know what's a black hole. A black hole is a place in space where gravity pulls so much that even light can't get out. The gravity is so strong because matter has been squeezed into a tiny space. So then, now that we know what a black hole is, what's a white hole? Basically, it's the opposite of a black hole. Imagine if you had a video of a bouncing ball and you play it in reverse. You'd see pretty much the same thing but backwards. That's what a white hole is believed to be. But then the question is, are white holes real? Theoretically, yes. They are allowed in Einstein's general theory of relativity. In fact, according to Einstein's theory of relativity, white holes are just as likely mathematically as black holes. Now, black holes from the death of a star are too young to have become white holes. But if there are any black holes that formed at the Big Bang, which is very possible, these could be old enough to have begun turning white. But if this is true, we haven't found any yet. So where do black holes come from? As I said, some may have formed at the Big Bang, but most form from supernovas, the death of a star. But we don't know what happens when they die. We don't know what happens inside the hole. Einstein's theory of relativity predicts that at the center there would be a singularity, a single point of infinite density. Time stops and everything vanishes. The problem is that at the center of the hole, gravity is so strong that quantum effects take over. Classical theory gets tossed out the window. Now, just as we don't know what's inside of a black hole, we don't know what happens at the end of a black hole's lifetime. The current theory involving information from Stephen Hawking and other scientists is that they just slowly evaporate and emit radiation until they disappear. The problem is that this violates rule number 1 of the first science class we ever took. Matter cannot be created or destroyed. Information cannot be lost. It has to go somewhere, but we don't know where it goes. This is where white holes come in. So there was a theory originally with electrons orbiting the atomic nucleus that this electron would just spiral down infinitely around the nucleus, but it was discovered that electrons have a finite bottom limit. It's the same with matter. It can get as dense as a flying star, but no denser than that. And so the theory around the death of a black hole related to white holes is that perhaps it shrinks until it reaches that finite bottom limit, and then it rebounds. There's a quantum bounce. The event horizon reverses. So instead of being able to pass it but not come out, anything can come out, but nothing can go in. Everything that fell into the black hole is ejected out of the white hole. This takes care of a lot of information. For example, the black hole information paradox. This is what I said about matter cannot be created or destroyed. According to the current theories, information entering a black hole disappears completely, but we know that information cannot be destroyed. So we have a problem here. It is destroyed, but it can't be destroyed. And then, perhaps even more interesting, white holes could be some or all of dark matter. Now, keep in mind, this is just one of dozens of theories about dark matter. But white holes are very hard to detect. We haven't found any yet. And they're made of some mysterious kind of matter. Some theorize that this could be dark matter. But as I said, it is just one of many theories about dark matter, which is a whole complicated topic on its own. Now, even crazier, the Big Bang might have been a white hole. You think about it. The mathematics of a white hole emission and the mathematics of the Big Bang's creations are very similar. We don't know what happened before the Big Bang. And this fits with Einstein's equations. We know how black holes are born, but we don't know how they die. And the opposite of that, Einstein's equations predict the existence of white holes, but not how they form. If you think about it, the Big Bang, bam, there's stuff. The white hole is also, bam, there's stuff. They could be the same thing. Now, there is, of course, a lot more to it than that. There's some information about how time works and more details of the theories and other theories. So I encourage you to check out these articles to get the whole story. And to check out NASA's site, they have a ton of information at all different reading levels, so you can definitely find something that you can enjoy. Thank you for listening, and let me know if you want me to just keep doing these videos for the heck of it. I would not mind.